So today we're solving absolute value equations. An absolute value equation is any equation that contains an absolute value expression. An extraneous solution is when we find a solution that we think is going to work in our equation, but when we plug it back in, we realize it doesn't work, and that solution must be rejected because it doesn't satisfy the original equation. Before we start solving absolute value equations, let's talk about some things that we know about absolute values. Absolute value is a number's distance from zero, so we know that anytime we're finding an absolute value, it's going to be positive or zero. Absolute values are never negative. Distances from zero are not negative. We also know that if we have two opposite numbers, they're going to have the same absolute value. They're both the same distance from zero, they're just on opposite sides of the number line. We also know that if we're multiplying two numbers and finding their absolute value, we can multiply them, find the absolute value of their product, and get our answer. Or we can find their absolute values, multiply their absolute values, we'll get the same answer. The same thing works with dividing. The only difference is when you're dividing, your second number can never be zero. We can't divide by zero. So if I'm dividing two numbers, I can divide them, find the absolute value of their quotient. That's going to give me the same answer as if I had found the absolute values and then divided. Same answer both ways. So let's get to solving an equation. So here we have an absolute value equation. Here's my absolute value, 3x plus 9. I also have a minus 10 and an equals negative 4. So the first thing I want to do is get this absolute value here by itself. So I'll add 10 to each side. So I now have absolute value 3x plus 9 equals 6. Now this absolute value here could be equal to 6, or this could have been equal to negative 6, because the absolute value of negative 6 would also give me 6. So I'm going to set up two different equations to solve here. This 3x plus 9 could have been equal to 6 or negative 6. So now I'm just going to go ahead and solve them. I'm going to get rid of 9 here and then have 3x equals negative 3. Divide by 3 on each side, and I get x equals negative 1. On this side, I'll subtract 9 from each side, get 3x equals negative 15. Now I'll divide both sides by 3, and I get x equals negative 5. Now before I say that these two solutions are definitely solutions, I'm going to want to test them out. So I'm first going to test x equals negative 1. I go back to my original equation. I'm going to plug negative 1 in for x. 3 times negative 1 is negative 3, plus 9 is 6. Absolute value of 6 is 6, minus 10 gives me negative 4. So this guy actually worked as a solution. Now I'm going to test out negative 5. 3 times negative 5 is negative 15, plus 9 is negative 6. The absolute value of negative 6 is 6, minus 10 is negative 4. So here I have two solutions. I'm going to try another problem. This time I've got the absolute value of 2x plus 12 equals 4x. Now this absolute value could be equal to 4x, or it could be equal to negative 4x. So I'm setting up two separate equations here. So I'm going to solve this one first. I'm going to get rid of 2x. And I have 12 equals 2x. And now I'm going to divide both sides by 2. And I get x equals 6. Now I'm going to try this one. I'm going to get rid of the 2x on each side. And I get 12 equals negative 6x. Divide both sides by negative 6. And I get x equals negative 2. Now before I consider these guys to be solutions, I'm actually going to want to check and make sure that they work when I plug them into the original. So I'm going to first plug in 6. 2 times 6 is 12, and 12 plus 12 is 24. The absolute value of 24 is 24, and 4 times 6 is 24, so this guy works. Now I'm going to try negative 2. Negative 2 times 2 is negative 4, plus 12 is 8, and 4 times negative 2 is negative 8. This side was worth 8, this side was worth negative 8. This solution did not work. This is an extraneous solution. So in this case, I only have one solution that works. X equals 6. All right, let's try 2 more. So sometimes our absolute value equations are going to have more than one absolute value. So in this case, I've got the absolute value of 3x minus 4 and the absolute value of x. Doesn't matter that there's 2. I'm going to solve it the same way. I'm going to set up 2 equations. 3x minus 4 could equal x, or 3x minus 4 could equal negative x. So I'll solve both here. I'm going to actually subtract 3x from both sides. Get negative 4 equals negative 2x here. I'll divide both sides by negative 2, and I get 2 equals x. Over here, I'm going to subtract the 3x from each side. Left with negative 4 equals negative 4x. Divide both sides by negative 4, and I get 1 equals x. So we're going to test out these solutions. So first, let's test 2. 3 times 2 is 6, minus 4 is 2, which is equal to the absolute value of 2. That one works. Now let's test 1. 3 times 1 is 3, minus 4 is negative 1, but the absolute value of negative 1 is 1, which equals the absolute value of 1. So we have 2 solutions. All right, last one. We've got 2 absolute values, but we also have this 2, which is outside of our absolute value symbol here. So I'm going to set up 2 equations. 4x minus 10 could equal just 2 times 3x plus 1. Or 4x minus 10 could equal 2 times the negative version of 3x plus 1. So negative 3x plus 1. So let's solve this guy first. So I've got 4x minus 10, and if I distribute here, I've got 6x plus 2. So I'm going to add 10 to each side, and now I've got 4x equals 6x plus 12. I'll now subtract 6x from each side, and I've got negative 2x equals 12. Divide by negative 2, and I get x equals negative 6. On this guy, I'm first going to distribute this negative. So I've got 4x minus 10 equals 2 times negative 3x minus 1. I'll distribute again. Now I've got 4x minus 10 equals negative 6x minus 2. I'll add 10 to both sides, which gives me 4x equals negative 6x plus 8. I'll add 6x to each side, and I've got 10x equals 8, and then I will divide each side by 10, and I'll get x equals 8/10 or 0.8. All right, so I can take both of these solutions, I can plug them back into my equation, make sure that both sides are equal, and in this case, x equals negative 6 will be a solution when I plug it in, and so will x equals 8/10. So once again, we'll have two solutions. But always make sure to take your solutions, plug them in there, and make sure they actually work, because you don't want to get tricked by an extraneous solution.